Hi, this is Ms. Fitzmaurice. This video is an explanation of free response number 7 in your review packet. So in this situation, we have two identical metal blocks. They're placed at equal heights on a frictionless ramp, and the blocks are released at the same time, traveling down and then sliding off their ends. Both of the blocks are leaving from the same height, and we know that block A leaves the table at a 30-degree incline. So this angle right here is 30 degrees. All they want us to do in part A is sketch the path of the two blocks from the time they're released to the time they hit the floor. So HA, slide down, obviously, and then it will fall like a projectile, where the path gets steeper and steeper and steeper. HA will do something kind of similar, except that since it's leaving at a 30-degree angle, it will rise to some other height before it hits the ground. Okay, so possibly these dots should be a little bit, there we go, closer in. But this is basically what your two pathways should look like. Part B, it asks us to indicate which block, if either, will be traveling faster when it reaches its highest point after leaving the table. Now, the answer to that is that H will be moving faster, and there's two different ways to show this. You could use conservation of energy, or you could use conservation of energy and then kinematics. So just conservation of energy. Okay, we're going to look at the block's highest points after leaving the table. For block, let's set this height, just for common reference, let's set this height, the height at which they leave the table, as being equal to 0. Let's set this height where they're both released as H, and then let's say the maximum height of block A is H1. Okay, so for block H, we know that energy is conserved, and energy is going to be conserved for both of these blocks. Sigma E naught is equal to sigma E, and basically we have the height. At the beginning, it has UG, which is MGH. At the end, at its highest point leaving the table, is at height equals 0, so it only has kinetic energy, and we have 1/2 mv squared. On the other hand, for block A, again we have sigma E naught is equal to sigma E, and for both of these, let's say at the highest, we don't know what this H1 is, but we know it's bigger than 0. So we still have MGH at the beginning. They have the same total energy at the beginning. And then we have kinetic energy, because this thing is still moving forward, 1/2 mv squared, plus mgh1. Okay, and to compare the velocities, I don't necessarily need to solve for v. but I need to solve for kinetic energy. So I'm going to move this to the other side by subtracting it. I have mgh minus mgh1 is equal to 1/2 mv squared. Okay, so mgh is bigger than mgh minus mgh1. Okay, so 1/2 mv squared is bigger for block A, and additionally, that means V is bigger for, for block H. Block H. Okay, the second way to think about this is to use conservation of energy and then kinematics. So we have both of our blocks, following this pathway where they're basically following this parabolic shape after they leave the table. And so what we can do is we can find the velocity at h equals 0 for both. And then what we can realize is that for both, v at the max height is equal to Vx as it's leaving the table. Okay, so we know that for both, we can use sigma E naught equals sigma E to find V as it leaves the table. Okay, and what that means is that for both we have mgh is equal to 1/2 mv squared, and v is equal to, if I do a little bit of algebra, square root of 2gh as it's leaving the table. Okay, then for h, Vx is equal to V, which is square root 2gh. But for A, Vx will be V times, if we think about the fact that A is at a 30-degree angle, it'll be V times cosine 30. And so we'll have the square root of 2gh times the cosine of 30, which is square root 3/2. And so VH is larger. In part D, we want to know if there is enough information to determine which block travels a greater horizontal distance before hitting the floor. Okay, the answer is yes. And it's basically a 2D kinematics problem. So what we can do to think about this before you start to justify your answer qualitatively is make an XY chart for both H and A. So here are my XY charts. Notice the main difference between them is in VOX and VOY. For A, we have square root 2gh times cosine 30, and for H, we just have square root 2gh, and then the VOY is 0. And what we can do for both of these is we can use the y direction to solve for time. So we can use this, and we can use this. And in both cases, we're using the first equation. So in general, whether or not we have H or A, we're using xy equals xoy plus voyt plus 1/2 ayt squared. Okay, and in both places, xy is 0 and xoy is ht. So we have 0 equals ht plus whatever voy is. I'm just going to leave it as voy for right now. Plus 1/2 at squared. We know that a is minus g, so I'm going to say minus 1/2 gt squared. Now if we want to solve for t, we have to use the quadratic formula. And we find that t is equal to negative voy plus or minus square root of voy squared minus 4 times ht times 1/2 g, which is negative, so this actually becomes a plus sign. We're going to divide the whole thing by 2a, so that's by negative 2 times 1/2 g. Of course, we can only have a positive time, so we're going to select the negative version, because we do have a negative sign in our denominator, and we just end up with t is equal to voy plus square root of voy squared plus 2ght all over g. What we're really trying to compare, though, is xx, so in order to do that, we need to use the first equation again, but in x. So we have, ignore this for right now, we have xx equals xox, plus voxt plus 1/2 axt squared. So we know that ax is 0, we know that xox is 0, and we have the distance that the thing lands along the floor will be vox times t. Now at this point, let's sort of break it up into h and a. For h, we know that xx will be square root 2gh, because that's our vox, times t for h. Since h doesn't have a voy term, this term and this one go away, and we have times 0 plus the square root of 0 plus 2g h all over g. Okay, and if I do a little bit of algebra, that will turn out to be 2g h over g, which is just 2h. Except, one second, these h's are different. My first h is different, and this is ht. So this is the height from which it was originally released, and that's the height of the table. So the 2 and g will come out. We have 2g over g, and then the square root of h times ht. The g's do cancel. For block A, on the other hand, xx will be equal to Vox, which is square root 2gh times cosine 30 times this whole monstrosity, square root 2gh plus, sorry, that's actually square root 2gh times sine 30. Okay, minus all this stuff in parentheses, sorry, plus all this stuff inside the square root, so Voy squared plus 2ght all over g. So this is actually quite a lot. I'm going to add the next term to the end, but it's still all over g. We have 2gh. Remember, this is different than ht, sine squared 30, okay, plus 2ght. Okay, so I've written these out a little bit more clearly so that we can compare them. Notice that every single term has a 2 and a g in it, so we can actually take the 2 and the g out, and we have square root 2g times square root 2g in every single term. I forgot to underline this one. And so we have xx equals 2g over g, and then we have the square root of h times cosine 30, and then inside we have this is inside the parentheses. No, square root h cosine 30. Inside we have square root of h times sine 30 plus square root h sine squared 30 plus ht. So we need to be able to somehow look at this and look at this and see if we can figure out which one is bigger. And we might want to simplify it a little bit more if we can. So we can write this as xx equals, we can distribute the square root h, so we have square root h times h is just h times cosine 30 sine 30, and cosine 30 times sine 30 is about, you could put it into a calculator, about 0.43. Okay, and we still have this 2 out front, so I have 2h times
0.43 plus 2 times cosine 30, which is about 0.87, 0.86, 0.87. And again, we can distribute this square root h. So we have the square root of h squared sine squared 30 plus ht. So when we look at this, hopefully you can see that actually, depending on the size of h versus ht, either could be bigger, so we can't tell. Okay, so finally, E is much simpler. Is enough information provided to determine which block, if either has a greater speed the instant it hits the floor? The answer is they actually have the same speed when they hit the floor. Okay, and you can prove this using conservation of energy for block H. Okay, let's now say that the floor has height 0 if we use conservation of energy. Sigma E equals sigma E naught. We can say that mg h plus h table is equal to, at the end, 1/2 mv squared. And the same thing can be said for block A. mg h plus ht is equal to 1/2 mv squared. If you solve for v, you get the same number both times. Okay, so now for points. Alright, in part A, there is 1 point. Okay, you have to draw both of these things correctly. Both of the pathways correctly give you 1 point. In part B, you get 1 point for indicating that H must be moving faster. So that's 1 point. You get 1 point for indicating that energy is conserved. You get 1 point for indicating that block A has more UG at its highest point. And you get your final point for comparing 1/2 mv squared, or kinetic energy in case H to case A. So that was actually only the first possible solution for part B. Okay, so either you get these 4 points, or if you went with kinematics, you get, again, 1 point for saying that VH is larger, so 1 point for the answer. You get 1 point for indicating that at the maximum height, the velocity is just Vx. You get 1 point for essentially showing that V is the same for each as it leaves the table. Okay, and then you get your final point for an expression for each Vx of H and Vx of A. And actually that combination of equations and explanation were for both B and C. For part D, so originally we said yes, you can do it with 2D kinematics, but as we showed later on, it actually depends on the size. So you get 1 point for that answer. You get 1 point for indicating that you needed to solve for time. You get 1 point for using the first equation to actually solve for time. Okay. You get 1 point for indicating that for both you need to use the first equation to solve for xx. 1 point for attempting to do so and getting to an answer for h, and 1 point for attempting to do so and getting to an answer for a. Finally, there's only 1 point, and it's for the answer.